point onward, we understand that if I have carbon, it has got 12 on top and also 6, if I'm not mistaken, okay? So now when you go to the periodic table, you see now elements on the periodic table, and these elements are written, okay, in chemical symbols, okay? So for carbon C, and we have 2 important numbers that you and I will have to know if we are going to perform very well in more concept. So we have a number on top. This is the mass number, and this is a proton number or atomic number, okay? So this is also called the relative atomic mass number, okay, or let's just say relative atomic mass. Now, this number is actually just simply the mass of this carbon as the average mass, okay, of the carbon. So what are you supposed to do now? Now you have to say, since this is mass, so meaning I only have one, okay, I only have one atom of carbon reacting in this equation, or actually participating in this equation. So what this means is that I have 12 grams. So I have 12 grams reacting with, okay. So now for oxygen, we know that if you have the periodic table again, oxygen is simply like this. Okay, so when you go to the periodic table, these are the numbers that we find on the oxygen atom. So we have 16, which is just the mass number, which is the average mass number of oxygen. So meaning, what scientists did was actually to have the averages of these elements in the that are found naturally. Okay, so whenever you're dealing with more concept, we always use the numbers on top of that element when you check out the periodic table, okay? So what this means is that I have 2 atoms of oxygen, okay? So I'm going to have something like this. So meaning the mass of this theoretical mass of this oxygen that was involved in the chemical reaction is meaning 16 plus 16, okay? So meaning I'm going to have 32, or you can say we have 2 atoms of oxygen, okay? So we can have 2 multiplied by 16, we are going to have 32.